Hi again, it's still Milan, and today we are going to learn how to visualize in a sort of artistic way using all sorts of vibrant colors a large Polygon dataset. This dataset covers all the habitat locations and habitat areas of mammalian species, and the data was sourced and created by the IUCN, and the dataset was published by IUCN, the International Union for Conservation of Nature. Let's see how we can visualize a global mammalian habitat dataset. See you in the Python terminal. I decided to visualize for this year's map challenge for the Polygon theme. We'll show the recorded habitat polygons, habitat areas of mammalian species. As you will see in the Python part, we will restrict the dataset to Europe so that it's easier to visualize and explore. But for now, let's see how we get the data. So I will also link this website as usual. And this is the website of the IUCN. And they have a really nice spatial data repository. Here you can read all the details, nearly 200k species, and 80% plus of them have geospatial data as well. And if you scroll down this website, you will see the datasets available for download. And here I will focus on the mammalian dataset, and within that I will download the terrestrial mammals dataset by clicking on the Polygon button here. But they have loads of other very exciting and extremely valuable datasets, so feel free to go down here and look around and see what you like and pick it and download it and visualize it. So once you hit download, you will need to describe why you would like to download the dataset. I've done this before, so I'm not doing it again, but I trust you will be able to do it fairly easily. And education is a totally fine purpose, and then you will probably have to saying something like Python tutorials, and then yes, it's educational. We will agree to the terms of use, and then we will have to go to our account page. Yeah, because if you're not registered, then probably you will be directed to register at this point. But it's real simple. You just have to sign up with your email address, and once it's done, you will be able to go to your account page, and yeah, like mine is here. And you can download the data and see all the saved downloads and all the queries you made before. So it's really simple. Just go for it. And now let's see how this works in Python. Again, the link as promised. And also a few imports, just the basics. Let's read in the dataset and give it a few seconds since even the zipped version is about 700 megabytes. And here you will see that altogether there are about 30,000 records in this geodata frame, which makes it a bit surprising how comes it's so large, and the reason is that the polygons are really large and very detailed, which show the habitat spaces. Let's just visualize one at random. Take one sample and then just plot it. And see, this is fairly large because these are in long and lat coordinates. And again, this is probably maybe a country, fairly large polygons. So to make sure we have something more manageable, I will crop this to Europe by first creating this bounding box covering most of the continental part of Europe, and then turning this into a bounding box geodata frame. And then restrict the mammalian dataset to Europe only. Then, once we have that, we can easily visualize it and color each polygon based on, for example, the tab 20 color palette with a fairly low alpha value, so they are transparent and overlapping, and making sure it's on this axis. Oh yeah, before that, let's use the reds. color map instead, which will show us a density map of the different species. So as you can see here, the largest number of species are here up in the northeast part and around here above Italy in the Alps and also in the UK, while the least number of species and overlapping mammalian habitats are here in northern part of Africa, which, well, in theory is not part of Europe, but it accidentally falls into our bounding box. So then we can make it a bit more abstract and artistic by using the Tab 20 color palette, which will turn this into a nice, interesting, almost like watercolor map. Now let's stick to this kind of watercolor map idea for a bit. Yep, maybe it's a bit too large for this screen, but it's nice. And for the next version, let's create more vibrant colors and the new color map called Neon using these few lines of code, and then plot the map. Again, we will use this axis we created, the new color map, turn the alpha parameter even lower. And yeah, we don't even need that because here we are not showing the line polygons. Okay, so now this looks nicer, even more watercolor styled, but we will need to do some housekeeping, switching the axis off and making sure that the background is all black and also that we have a tight layout. And yep, now this is starting to look like a nice artistic polygon map. Then, just to make sure we know where the polygons are, I will plot the boundary lines in white, which will give this a very interesting twist. And besides the nice watercolor-like coloring, it will also sort of highlight the species densities. So where we will see a lot of white lines, we will have probably more species habitat boundaries, which way the Alps will emerge, for example, or here around Hungary as well. So yeah, so this is a nice polygon map, but I actually wanted to go further here and create an interactive version of this with volume. So let's see how we can reproduce this or something similar in volume. After a few additional imports, I will create the map, placing it or centering it around the approximate center of Europe and using zoom level 4. Then I believe that we will need to recreate the color map so that it matches the interface of volume. And then we will visualize every single polygon one by one within a for loop. So in this for loop, we iterate over every row in the European Polygon dataset, pick the color based on the index of the polygon in the data frame, then create a unique tooltip which will tell us the scientific name, the ID, and a few other parameters about the species that a certain habitat polygon belongs to. And then we also make sure that we add the GeoJSON polygon as a layer to the map. And once we have done that, we can save it and visualize it either here in the notebook or open it afterwards. And this will run for a few seconds, so let's just finish the code. While in the meantime, I will open the final interactive polygon map and show you how it looks like. After that polygon processing code and visualizing code finishes, we will have an exported map which will look just like this. So here you can zoom in. This will be still fairly large because the dataset and the polygons are very complex. So if your computer would be struggling with that, maybe you can just run a simplification command on them, on the polygons. But here if we zoom in, we can actually select a polygon, and we can see the type of animal this is based on its scientific or Latin name. We can read its family and a few other information, and we can also move around on this map as we wish. This is how we can build a nice polygon map with an artistic touch and also turn it into an interactive visualization. So thank you for following it through and see you next time.